Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Kyle from Business Review, and I'll be your host today. It's our pleasure to have Precognize with us, who's presenting this webinar entitled Analytical Monitoring Centers for Process Plants. Those guest speakers are Chen Limchevsky, CEO at Precognize, and Fokion Tasules, Group Engineering and Technology Executive Director. I'd like to welcome you all to our webinar platform On24. You'll notice that this webinar is browser-based. So if you disconnect for any reason, please just click on the link you received by email to rejoin the session. If you want to ask any questions, you can send those in via the questions widget. Just type your question and the name of the presenter you're directing it towards into the box at the top left-hand corner of your screen, then click submit, and we'll have some time at the very end to address any questions or thoughts that you may have. Please use the yellow help widget if you require any assistance, and you can move, resize, and maximize any of the windows in front of you to get a better view of the slide. But for now, please allow me to welcome Chen Limchevsky. Over to you, Chen.
Thank you, Kyle, and thank you all for joining, especially in these crazy Corona times, where some of you are working remotely, and I know it's not very easy. So today we'll talk about the analytical monitoring centers, especially for process plants. Before we do that, a quick word about us. Our tool called SAMGUARD, and basically it's a human-enhanced machine learning software. And by human-enhanced, it means that when we started the company several years ago, we understood that machine learning is not enough in order to solve the complexity of the process industry, and you need to enhance it with something. And actually, this something is the knowledge of the engineers and topology of the plant, which we inject into the machine learning. So today, the software is mature, and it's actually combining both the human factor and the machine learning capabilities into a comprehensive tool. About 2 years ago, we were acquired by Samsung AG, which is a big flow control company, and by that we are now able not just to bring the innovation and machine learning and AI, but also combine it with a lot of instrumentation knowledge. So I think we're the only company in the market that actually integrates the vertical from from the bare valve to the holistic view of the entire plant. We're specifically focused on the process industry. We think that the problems in the process industry, chemicals, petrochemicals, refineries, oil and gas, and also cement, as you will hear later on at the second part of the presentation, those plants have specific needs which are not similar to discrete, and the solution has to be really geared toward this industry. And we're now all over the world. So this presentation is made during the hours that are comfortable for our customers and prospects in the US, but of course we're in Europe, Asia, and so on. So that was just briefly presenting ourselves, and during the presentation I will not talk too much about SAMGUARD and our capabilities, so if any of you is interested to learn more about the tool itself and the capabilities and so on, please contact us afterwards, and we'll be happy to arrange a specific demo. So as I started, we're in the strange times now. The COVID-19 it's actually changing everything that we knew about the world. Now we can take it as something that is not good, and of course there are really bad aspects to that. But the one thing that I'm sure about is that whatever we did in the past will not be enough for the challenges of the future. Okay, so I'm not sure what the changes will be. I'm not sure how the world will look like when we all go out from our homes and get back to work, but I'm sure there will be changes, okay? And we are part of a very conservative industry, an industry that, Titan is manufacturing cement for more than 100 years. Samsung exists for 112 years. So it's very important for us to understand that after the corona, the things that we did in the past may not be enough. We need to change our natural conservative view and start looking where can we do things better. So of course this is relevant without the corona. We always try to do things better, but after the corona it will be a necessity. It will not be anymore that we can say maybe yes, maybe no. And when it comes to our area in the process industry and to analytical monitoring, I can point 3 areas where this is really, really meaningful. The first thing is equipment failures. Okay, something breaks here, something breaks there, something breaks there, and many of the plants that we're seeing in the industry are chasing fires. Okay, something breaks, we go and fix it, and so on. Now, chasing fires is okay when you have a full stop on the ground and everything is going, you're well prepared. But if suddenly a valve, a pump, something is breaking, and you have only skeleton team, suddenly it's not funny anymore, and you don't have parts in the inventory, and the manufacturers also have troubles to supply and all kinds of things. Now it's not okay anymore. Okay, so the fact that we're chasing fires and failures are coming as surprise are always bad, but are unacceptable in the corona and post-corona time. The second thing are the things like process deviation. Okay, something is not working exactly like it should. There's some kind of deviation, or somebody did in the control room something that he wasn't supposed to do. And actually, we are in the plant, so we go into the control room. What's happening there? Why is it like this? And we kind of catch it. Now, this over-the-shoulder thing does not exist when you work with a skeleton team. This over-the-shoulder doesn't work when you work from remote. It doesn't work in the new era where things need to be more better monitored and better addressing the fact that that we're not there to be not prepared. And of course, the third thing is that maintenance is done in periodic routine. Okay, and we don't really pay attention to things like maybe this can be delayed, and this thing or this other equipment should be replaced on time, just because the health of that specific part. Okay, so with all these things, we're coping every day, and I'm sure you do cope with that every day. The thing is that now it's going to be much harder to cope with it. And it's, of course, was harder during the corona, and it will be harder when there will be the second wave of the corona. Hopefully it won't, but it may. And it will be harder when there will be more and more things that will affect us in the future. Okay, so the ones that came prepared to this situation, the ones that now failures are not coming as a surprise. They know 2 weeks in advance that something is going to fail, and they do something about it, and they prepare. The ones that every deviation is suddenly jumping up, these are the ones that came into this corona crisis much more prepared, and they went through it, in a much more painless way. Now, what I'm trying to pitch here is that basically in the new post-corona reality, if you're using analytical monitoring, it can help you address those challenges. Okay. It can help you in the pre-corona, but for sure in the post-corona. So what is analytical monitoring? What am I referring to? Because there are many buzzwords in the market, like predictive maintenance and analytics and machine learning and AI, and then that. Let's make clear what are we talking about. What is analytical monitoring? So analytical monitoring for us is actually when we're looking at the plant, there are so many parts there, thousands of different parts. There are so many processes that are happening in parallel, one after the other, and so on. There are so many things that are happening. The idea behind analytical monitoring is that we're able to monitor all the processes, okay, all the equipment, and create predictive alerts which are based on advanced analytical technologies, okay? So the idea is that we can tell you and give you an holistic view of every part in the plant, not just the ones that are really, really important, because every plant can fail, and every process in the plant, and give you a very good information about the health of the plant so you can be prepared and not work in chasing fires. And this is very, very significant, okay? Now, you may say, okay, you know, actually we have a tool that covers the entire plant. And this is, of course, our regular control room alerts that are coming up. They're also covering everything. And this is the second part of analytical monitoring, the analytical part, the using analytical technologies. Because what is happening in the control room is that you have some kind of limits which were designed somewhere at the beginning of time, where you have usually a warning, and then you have a severe, you reach a severe limit where you actually get an alert and you need to act upon it. And it's usually working on a single tag, single point of data, and it was pre-programmed into your control. Okay. Now, when you're talking about analytical, this is completely different. Now we're talking about something that is actually taking all the tags in the plant, all the data that exists in the plant, and look when things are actually working normal, that the relationship between the tags are actually working normal, and if they're not working normal, then it will give you an alert. Now, the nice thing about analytical solutions is that they're not pre-programmed. They're constantly learning. So you replace the part, okay, the system knows that you replaced the part, and now it will look for the new normal, and it will constantly update itself. So it's not something that at the beginning of time somebody put a limit. It's actually something that is constantly learning. And what it enables us is to be much earlier than the control room, okay? So actually when you see, when you get an alert from the analytical tool, you get it much earlier and way before the control room will provide you any alert. Okay. The second thing that is really important is that it's much more accurate. Okay. We're all used to ignore on the alerts in the control. In SAMGUARD, usually we have like 2 or 3 alerts a day in a normal plant, which is not failing very often, up to 5 alerts a day. So it's much more accurate. So you don't have this alert fatigue thing. That is very common, and it's holistic. Okay, so if think of your entire plant, everything can work. So it's just like your control set, just like your control limits, just it's much earlier, much more accurate, and pinpointing the real problems. Now, the context of this webinar is about the Analytical Monitoring Center. And at this point, I would just like to mention something that we'll cover also later on, is that why do we need a center? If you give those great early alerts, those things are really, you tell us in advance something is going bad. Why is there is complication here? And I want you to remember this slide for one reason. Look at the warning limits of the control. When you look at the warning limits of the control, the operator today, according to the known things or the known methods that are used in the plant, if something reached the limit, he knows there is a problem. Okay, so this is the way we used to see problems in our plant. It reached the limit in the control. Okay, that's the obvious thing. Now, the alerts that were provided by analytical monitoring is always before the warning. Okay, it's always before the warning. So remember, It's actually covering everything like the control room, but it looks at it from a completely different perspective. And when it looks at it from a completely different perspective, it's much earlier. And much earlier is great because it provides us an early alert. Much earlier is creating a challenge because people are used to addressing problems only when they get to the control limits. So just keep this in mind. So when we're talking analytical monitoring, it's actually another layer on top of the control room alerts, much earlier, accurate, holistic. The second thing that you may ask yourself, okay, when you talk about analytical monitoring, how is it different from all the trending and visualization tools that we have in the plant with TrendMiner, Seek, other tools, Tableau, other tools which are used for visualization, trending, and so on. And here, keep in mind that we're addressing a completely different problem. Remember the 3 targets that we put at the beginning. We want you to stop chasing fires. Okay, we want to know in advance that there is a potential failure. We know to address those small process deviations, not the ones that you optimize through those tools, but the ones that you didn't look at and are now starting to drift. And you want to learn about the health of the parts. So these targets are not met by those tools, which are excellent. Okay, I have no. They have their objective and they have their targets. And if you're now trying to optimize a specific thing, probably that would be your tool. But if you're trying to monitor your entire plant and look for those unforeseen events, okay, then probably what you're looking for is analytical monitoring solution and not trending and visualization solution.
The thing is, it actually works. Okay, analytical monitoring is now, as we will hear later on from Fukion, is really working in large scale at process plants. Now, in order to make you feel more comfortable about it, I just brought 2 examples, one from equipment failure and the other one from process. What we see here is a compressor failure, a joystick compressor, not the major compressor, but the instrumentation compressor. Now you can see that both tags that are shown are actually vibrations. None of these vibrations, I can tell you, is off the limits, of the operation limits. Yet something in the relationship, something in the way those vibrations started to behave is indicating a problem to the system. It is not that we're looking for a specific pattern. Probably those patterns never happened before, but something is not working in the same way it used to work, and as a result of that, trigger an alert. Okay, these are the kind of things that analytical monitoring is doing for all the equipment in the plant. Another example I want to share with you is from a process problem, blockage in a furnace. Now, these problems are usually much harder to explain, and only the people who are really dealing with this furnace can really understand. But the really important takeaway from that is the difference between the area marked with the blue arrow and the area marked with the red arrow. Now, in the blue arrow, something changed with the data, but this change was okay. Everything moved in the same relationship and probably happened in the past. If you look at the red arrow, this is an area where actually the air temperature remained the same at the baseline, but the product temperature drops to a constant value. Okay, and this indicates some kind of problem. Now, the most important takeaway from this slide is about analytical monitoring, and that's the fact that you're only alerting when things are important. In usual, what we are providing is anything between 0 to 3-5 alerts a day. And this is what you can expect, not hundreds of alerts every day like you currently have in your control system. So the question is not,
do we need it? Should we do it? Is the technology there? Yes, no. It's not in the if. The real challenge is around the how. How do we implement analytical monitoring in the best possible way? And if any of you think that you're going to stay with your limits in the control without adding any analytical capabilities, without adding the capability to monitor the plant much better, in the long run, I'm telling you for sure, it doesn't matter if you select our tool or some other tool, you're wrong. it will be part of your standard implementation. So the question is not if you do it, and the question is not if the technology works.
The question is, how do we implement in the best possible way? We see three options to implement the analytical monitoring. The first one is to use the existing team. In such case, the alerts are presented in the control room. The control room people are looking at it, either do whatever they need according to the alert, or forward it to the process engineer who is responsible for that area. Now, there are a few obstacles with this approach. The first one is that, remember, all the alerts are within the control limit. Okay, these guys are used to something else. The second is that these guys are busy, okay, especially the process engineers. And you just add another tool, although it's only, very few alerts a day, still it's another tool to look at, more problems to analyze. Those problems are of course, will prevent more severe problems later on, but at the current point, it's actually additional work. So if you want to overcome these obstacles, what you need to allow it time and management support. It takes anything between 6 to 18 months to gain confidence with the existing team. And it would take at least bi-weekly meeting with the management to really go deeper into the reviews. The projects that failed completely are the projects where the management just gave the tool to the existing team, didn't provide them more time, and then came at the end of whatever the pilot time was and asked, what do you think? Okay, the what do you think is actually leaving the decision to the people in the field who actually don't have time to make this decision. So unless you really can allow the team to focus or to have time to look at this solution, this would not be my favorite option. If you're afraid that your team is not capable of doing it at this current time, okay, then what we recommend is to do what we call Plant Analytical Monitoring Center, which is within the plant. It means that you put a dedicated person, which all what they do is look at the alerts, understand what the problem, follow up on the fixing of the problem, following up on the value of the problem, seeing if there are any data problems that need to be fixed, understanding how analytical solution is going to be implemented. And once they're done, then not just that they are trusted, it's also that the solution is trusted. And now you can start transferring it more and more into the actual existing team at the control room. Now, this option may sound very expensive, yet if you think of scale, if you think of taking it from the first plant and moving into 5, 8, 10, 20 plants, now actually at this time, this option is probably the most scalable internal option that you can find.
The third option, which we'll also talk about later on, is the remote analytical monitoring center. And there are many advantages to do it from remote, because if you're doing it at one place for all the plants, you're actually gaining some vertical knowledge, which enables you to do things in a much better way and improve. Okay, so all these options are available. All these options are we have experience with all three of them. And all three of them may work. And with that, what I would like to do, I would like to ask Fukun Tasulas, who in the last 2 years been working together on the implementation of SAMGUARD at the Titan, and since then became a friend, to share his experience about those three options, about the implementation. And what they learned during their journey of the last year and a half or 2 years of working on analytical monitoring. Okay, the floor is yours.
So, thanks a lot, Ken. I hope that we'll have a better luck than you with my connection. It's really an honor being here with you. As you mentioned, after 2 years of hard work and a lot of challenges, we became friends, and I'm very proud of that. And also friends with the whole old Precognize and now SAMGUARD team. But first of all, allow me to a little bit try to describe from where we're coming from. We have, as a Titan Cement company, whereas SAMGUARD, my friend Hen presented, we have a very big history and tradition in cement. The company founded beginning of 20th century, and from that time we are running the business with the same family, actually, with different generations. The company is listed by 1912 in the Athens Stock Exchange. Is one of the oldest 3 companies that are still exist there. And from last year, we registered also in Euronext in Brussels. Our, let's say, foundation and what really give us the business opportunity and the business operation plan is our 14 cement plants in 10 different countries. And as you can see here in the bottom of this slide, last year we had around 270 million euros of EBITDA. And if we move to the next slide that you will see here, our geographical presence, you see that we have presence in all 5 continents with a strong network, not only of cement plants that we said, but also with cement grinding, with cement terminals, with distribution terminals of cement and aggregates, but also strong business on ready-mix concrete plants that are integrated with our cement plants, and also aggregate quarries, fly ash, and so on and so forth. At that stage, I would like to a little bit describe as an overview of the group what exactly we think value exists and how. We strongly believe as a group, and that is a depiction of exactly how our executive committee and our board is thinking. What does digitization and automation means for us, and why we're striving to find such tools? We believe that there is a lot of opportunity to do more efficient and effective business in the value chain of building materials. So we see the whole value chain from a supplier to a customer of us as an opportunity to do better business. And how we do that, we try to connect all these different parts of the value chain in one integrated real-time data platform. If we go then through all of this value chain, you can pick and choose different areas that you can optimize your performance, utilizing real-time optimizer, utilizing artificial intelligence, machine learning, and big data. And that's exactly as you see here, we have a lot of opportunities. And today we will focus on assets analytical monitoring that is part of this presentation that we are talking about. The main difference that I would like a little bit at the beginning to describe with you is what we found behind this SAMGUARD tool and what was the problem, what was the challenge that we tried to face and why we selected that. What was the problem we tried to solve with that? As Ken mentioned earlier, we live in a cement plant, and most of you that you are part of this process industry 24/7 running operations, you know how the control room is looking from outside. It's a crazy place that there is always somewhere there for the years that the plant exists, every second, and the whole thing is flooded and overwhelmed with data, alerts, noises, different screens, and so on and so forth. So our control room operators, our engineers, our process engineers, our maintenance engineers, they are always reacting on some cases of alerts, on some cases of emergencies, or as Ken said, trying to chasing fires. What we wanted is to give the opportunity to our people at different levels with different agendas to look a little bit the bigger picture and try to manage by exception and try to be proactive and try to make our business more reliable, to have lower cost, significant lower cost. So that's exactly what we found in this use case that we launched together with Precognize at that time. We wanted to have a tool to give us the opportunity to introduce to our teams a tool that they can work with, a solid tool, and they can manage by exception and not with the flooded information, avoiding the information overload that they are going through every day, every second. So this will give us our people and our teams to utilize more their troubleshooting capabilities and to deal with the important things and not consume everything with their urgent, as we described to the left side of the slide. That we will strongly believe at that time it will give us an opportunity to reduce our costs and improve significantly our reliability of our assets in our cement plant. And this, we can do it, as we said, if we move away of the continuous surveillance to what we call to monitor the behavior of different equipment, the behavior that is induced either by maintenance failures, the behavior that is induced either by stress-related failures because we operate a lot of our equipment outside of the safe rates, and everybody of us wants to operate this, not 100%, but 100% and 110%, or our parts, they have wear and tear, and we need to take care of them. So, and allow me a little bit now to look on something that most of you are familiar, and I don't say that I'm bringing something new, but I really wanted to share with you this particular slide that you can see here to the left side, that what is in general the concept of a failure. We have a huge path from where a failure starts to occur, and we don't have, high signals. We have some very, very small noise on that. But gradually as we go, especially if we talk about maintenance, about parts, we can hear them, we can smell them, we can see them. As you can see in this graph, the right part of the curve. But that, it's very late. And then the breakdown happens. Also, if you see during this curve going down, the cost of repairing something is going up. So what we want with such a system, what actually we achieved was to have a very early detection of the failure, to measure this failure and touch this failure very early. So we'll be able to troubleshoot this and take care to repair without any cost at our time with a good schedule. So what exactly Ken presented and addressed earlier, we saw this with this tool, how with our big data that we are using from our platforms and our automation systems, like CEMAT or ECS from CEMAT and other systems that we use, with machine learning over them, we can detect anomalies and alerts with such changes at a very early stage of a failure. And allow me here to make a note that when we say failure, it's not only failure of a part. It might be failure of a process. It might be even failure of a quality. Think about an early stage alert on a quality failure that otherwise you will see at the end how much impact has a low quality product if you don't manage to see it earlier. So with this tool, and of course with our functional experts, we could review the events that we're getting out of the system, and we can also adjust the threshold of how many events we can go into get gradually, so to test them and get of them out of them the best results. And allow me to share with you some of these things that we've got, and all of these, as you will see later, are from the first implementation that we really strangled to get through of this and really to test and prove the concept. Here is an alert. You know, in the cement plants, we use huge assets. This is the cooler after the kiln that quenching the clinker from 1500 degrees of Celsius to 150 degrees. So it's a huge piece of equipment. It has a lot of motors and cooler fans. So at first stages of this implementation, the team knew that these motors, they don't have any power meters. They don't have any aberrage on them. They don't have anything. But only from the process signals and the process controls that we had about pressure of the air, about temperature profile in the cooler, the system created an alert. And here you can see to the left side the first warning. Okay, the team did not react. That was okay. Why this system is giving such an alert? They don't even know how to measure the power that is absorbed from this fan. The second alert after 3 days, same thing. After 10 days, the motor failed. That was really a wow moment for the team. They said something is really going on here. And then again from this plant, I would like to share with you something that was mentioned earlier. That system can detect abnormalities and potential failures even if things are much lower and the measurements are much lower on any alarm level. Here you can see a picture of a fan. That's a big fan, as you see to the left side of the picture, with a motor that controls the raw mill that we are grinding our raw materials. And this fan has an installed capacity of 2,000 megawatts. And we had a vibration monitor on the fan. So what you see here to the left side in the graph is at some point we saw the vibrations, these vibrations picking up. The system alerted us. Vibrations are picking up after the first time, then after 2 hours, the same thing. But this was far below the limit. So what was the root cause of that is what you see here, the broken damper to the right corner of the whole system. Of course, don't look this as it is to now, because now it's very well cleaned. That was covered with a lot of dust. And if that was going to be unnoticed, after 1 month, probably we'll have an alarm to the vibrations because we're going to exceed the level of alarm, but probably the bearing of this motor will be destroyed. So these was 2 examples that really shaked the whole team, the project team that were doing. They said, guys, here this is something that is real. It is something that we need to make it happen, and I will tell you later how we made it happen. And if I go now, during the coronavirus, even now, continues the way that we were working with simple things and simple alerts, we can make our life easier without having a lot of people outside, let's say, monitoring piece of equipment or trying to find, let's say, silly spillages that are happening here or there in a plant that might have thousands of meters of belt conveyors. And what you see exactly here, that we have an alert on the top graph here, that a belt conveyor power absorbed has an abnormal behavior. And something happens there, so immediately you can see and you can find the root cause of this, and we can focus exactly to use one of our employees from this skeleton crew that we have all these days. All of you, you know that. We try to keep our people safe and strong and healthy, so we use half of these shift people, so it's a luxury to have people going around. But with the system, we're doing what we'll continue to do what we are doing. It proved to be very helpful for that. So overall, and I would like to really share it with you, what we saw, and that's a graph that you can see here, is the reliability factor of the kiln. In a cement plant, the kiln is the heart of the whole process, of the pyro process. And you see here that we started implementing in this plant, that was the second plant that we did the implementation, the SAMGUARD sometime during May, if I'm not mistaken. And then you see gradually up to now, we did an excellent job in increasing the reliability in levels that we never saw in this plant. And I have in red line in this graph what is considered as a world-class performance. Everything above 98% reliability factor in a kiln considered in a world-class performance. And all the time after, let's say, the end of last year, except of a small time after the startup of the annual outage, the kiln is running above 90%, sometimes reaching 99.5. And from that, it's not only that we earn a lot in maintenance cost and lower maintenance cost, is that we are producing much more. And in this plant, we have increased our annual capacity because of that by 5% without paying anything more in the installed capacity. Also, our repair cost and the labor cost went down. So on that, again, trying to give you and depict a little bit the benefits that we have seen and measured in this same plant during the last 10 months, we saw that the avoided cost as we measure, it can reach at 10 months time around $900,000, and we calculate this to be annualized around 1 million, and you will see later in another graph. And also the avoided downtime in very important assets like the kiln or the finished mills that are grinding the final product to be around 500 hours. For us, it's very significant impact in our processes and in our operations, and has a very high ROI. But let's take a little bit a back moment and seeing how these all things started and how all these things happened. 3.5 years ago, at the group level, before we have started this with SAMGUARD, at an executive level, at an executive committee level, at the board level, we had an awareness workshops. We have 2-3 awareness building workshops about digitization and the way that we'll move forward. And all of us, we agree that then one of the outcomes of this learning curve was this, as we called here in this slide, the test and learn approach. We said, guys, we will go with experiments with a lot of pilots, and we will try to verify fast the impact and the implementation requirements. We'll try to build our capabilities and our infrastructure. And for the projects that we will see immediately that there is a good return on investment, we will try to scale them up very fast to different business units, and then we will try to capture all this impact across all the group and across different areas, and align this with our strategy, the Titan strategy from our values and the management objectives. That one of them is continuous improvement and operational excellence of our plants. So that was the initiative, and that was how we really test this idea of implementing SAMGUARD in our plants. Having this, we start thinking how we can start small. What is the most critical thing? Because we had the software, we had the vendor, then we wanted to have a plant that should be an average plant. We tried to build our approach on this project. The first and most important thing for us, we need to have an average plant, not very sophisticated in automation, not very, used with new tools and this, but most importantly, we want to have a strong management team that will be connected with us. We have the same objectives, and we will stay on top of this when we'll try to test this and try to implement that. So having that and agree that with the executive management of the region and the country, we then decided with them, and we try to identify the roles between the central team and the local team, and then we moved ahead to roll it out in this cement plant in a lot of different modes that it's a little bit common what described earlier, Ken, and I will try to explain this a little later. As you see here, we first try to roll it out and test all these results and see if we have better predictability from the events that we are getting. And also, we tried to implement this, engage our people better from different days. As you can see here in this slide, that I would like a little bit to draw your attention, you will see in this slide a lot of different time frames. That was the first plant. After some weeks, months, we had a good proof that this system was working. But we were not sure that we are getting 100% out of this. So we tried to go down and see how to really design a blueprint of this implementation, how to engage the peoples of the plant, what kind of signals we need to incorporate, how we connect this, how we will prepare the digital twin of this plant in that system, how we connect the plant with the server of SAMGUARD, what kind of team we need to have this. And I have here to say, and I'm very glad that Ken mentioned that, it was one of the very lengthy discussions that we had, that we went through all these three, let's say, cases that he presented. We started first with the control room. We had this system in parallel with all the rest of the systems that we had, and we tried to engage the control room operators and some of the young engineers that we have to follow this up and troubleshoot this. Unfortunately, it did not work. So we sat down again with Ken and his team, with the plant team, with the management of the plant, and we said, guys, we don't get the attention that we want, we don't get the right troubleshoot, so how can do better? And then it came up out of this that the best probably option now is to have one guy that has the responsibility of this, but also this should be a guy from the top management team, a technical guy from the top management team of the plant that has not only the responsibility but has the authority to mobilize different people from different functions, to put them together to try to troubleshoot the events, the alerts, to find the root cause of the problems and fix them. And we also set a very specific program, schedule, daily schedule, that this team of 3-4 people, they will, every day they will have a meeting, no more than half an hour meeting before the daily meeting of each plan. They will troubleshoot, they will try to give the guidance, and the next day they will review. That's really something that it worked. That was what we learned in 1.5 years. So after 1.5 years, we had the blueprint how to implement, what is needed in hard and soft skills, how we will govern this, and then we moved to the next 2 plants. And if you see, the second plant that was far away of this one, in another geography in the US, it took us 2 months on the ground implementation, meaning with physical presence of the corporate team of 1-2 people. You don't think that it was 5 to 10 people. We did this, we made it live, and then in parallel, we implemented this in a second plant in the US. That took us less than 2 months. It was almost 1 month. And then we came back in our first strategic drivers of this implementation. Now we had 3 plants, and we thought, why we need to have 3 different teams in 3 different plants with the level of expertise that each plant has. Some of them, they are very knowledgeable, some of them, they are young, some of them, they are learning, some of this. Why we don't try to combine all this in one remote analytical monitoring center? Establish a remote center that it will have connectivity with all these plants, will get all these alerts, and let's try again to test the governance of this connection with the rest of the plants and try to see how it can work. So doing a step after the one, you saw that we started small, we tested one approach, we tested the second approach that worked, we moved to other plans, we have 3 teams working now. We said, why won't do one team then? Then we set this remote monitoring center that you can see here in this picture. This is the screens, and we have some ugly people there. We took them out from there to take the picture. We established this remote monitoring center, totally outside of any cement plant, somewhere in the US. And this plant is 24/7 connected with our plants. It's connected with SAMGUARD, and then in different contexts. And then people that are high level and deep domain knowledge, have deep domain knowledge, expertise on maintenance, on process, on troubleshooting, they are sitting there and they monitor the performance of all these plants. They monitor the events of all these plants, and they connect regularly with these plants and they measure it. So what we succeeded to do is to have another, let's say, kid in the block that we have incorporated in this remote center, the 2 US plants and the other plant that was in Europe, the first one. And then it was by accident that coronavirus happened, that we had already scheduled to implement this in 2 different plants. So with the team that we had in our corporate center and the team in the remote monitoring center, we had the opportunity to do a remote rollout for us in really very low time. In 3 weeks, we did the 4th plant. In 5 weeks, in 2 weeks, we did the 5th one. So now, as you see here in the graph, we try to depict the whole history. We started slow, we proved the concept, and now we build an experience of a remote monitoring center, monitoring 5 different plants, and we try to see what it will take us in terms of resources, of connectivity, to tie in all our cement plants and have one central remote monitoring center that will capture all the value of troubleshooting, of best practices, of everything. What is critical for us, and now we are experimenting on this as always, and I don't want you to stay in this very, let's say, busy slide. It's probably that you can see it later. We try to establish a kind of strong communication and governance system between the remote monitoring center and the plant teams, responsibilities and accountabilities on that, opening and closing cases, troubleshooting and doing things faster and more accurate. So what our people in a remote monitoring center, they are doing is we have them there. As I told you, they are very high level experts on this, and they monitor the events that are coming from the system every day. At first, they have the tools, and through the system, the access on data, so mostly they can do combining different parameters, different signals, and different cases from process quality and everything. They can do a first root cause analysis themselves. They communicate there with the plants, and they have an open dialogue, what actions they should be taking at the ground level to fix all this. Of course, these guys, they collect all this at the remote center, and they provide regular information and reports to the management, because on all this, the management of all plants is heavily involved on that. It follows up every day and every week and every month what are the results and what are the KPIs that are related to the performance of the system and the findings on them. So the life from this first, let's say, months, weeks, I would say, in this Central Analytical Monitoring Center is that really the system works. The system works from a distance. The system gives us alerts. Sometimes it gives us alerts that they will never be notified otherwise. And the teams are building a very good, let's say, communication and very trustful communication with openness and transparency, with facts. They do fact-based analysis. They share their knowledge with the frontline guys that are going to take care of the findings, and they communicate and they build very good relations if the system works. And we now try to identify exactly what is the needed resources that it will take us to build, to expand this remote analytical center for the whole 14 plants that we have in our group. So if we look strategically, the key objectives that this analytical remote monitoring center gives us, it gives us different, benefits at cement plant level, at remote center level, and at the group level. At cement plant level, as we discussed at the beginning, it gives us reduced downtime, increased availability of assets. It organizes in advance the repair, so we don't need to mobilize people all by sudden, nights, this. It supports with low-cost repairs. It avoids high-cost repairs and catastrophic events because early enough we take care of them. And for the ones that you are from cement operations, you know that most of the downtimes that we have in big assets are not coming from the asset percent. We don't have a lot of kilns that are cutting in the middle, but we have a lot of pumps, a lot of compressors, a lot of blowers, a lot of motors, and those that are out of operation. So the system, it takes care mostly of everything on that, but also of the kiln itself. So if we go from the cement plant level to the remote center level, we see that here we have now the blueprint that we can accelerate the rollout in the implementation. We now, with some people that are focused on doing this not as a side job, but a day in, day out job, they build new capabilities. They master troubleshooting. They learn. They collect all the experience for all different plants. I've heard a lot of times, because some of them I know personally, that what we saw today is exactly what we found out last week from another plant. So in the cement plants, there are no magic, failures. Most of the things are occurring and occurring again and again. The problem is that not the same people, not the same time, with the right language are there. Our plants, our cement plants, they have turnovers, they have people that are missing, they have super busy people. But here we have something that is isolated. The real reason that they exist is only to troubleshoot. So that's something super important for us. And of course, they act like a glue, like a connector that really brings together the whole plant. Because when we have a case that says, we found this failure is expected, that's the action that we need to take. This action has been taken 1 month ago in plant in the US. Now you need to implement this in Egypt. Call this guy to give you all the instructions about that. So we build such a team spirit at the global level. And of course, at the group level, then we feel that we can capture all this methodology. We can build best practices. We can monitor the performance and the KPI through this globally. We can benchmark. We can compare. So really, we are very excited about this, and thank you very much for this opportunity that Hen gave me to communicate with you our experiment, our struggling, our achievements, and our plans for the future. Here we are.
Okay. Thank you very much. So I'm afraid we've gone a couple minutes over, so we may not have time for a live Q&A today. But please do still send in your questions, as you can still be contacted by email. So same way, just send them in via that box in the top left-hand corner. Just address it to a presenter if you want to ask it specifically, and then keep an eye out, as you can still be contacted later on. Okay, but otherwise, that just leaves a big thanks to both our presenters. It was a great presentation. And of course, the Preview for sponsoring this session. To everyone watching, you will be receiving an email shortly letting you know how to access the on-demand version of this webinar, or you can always watch it through our website, which is www.business-review-webinars.com. Thank you all once again, and I hope everyone enjoys the rest of their day.